decided to put the list together for brain credits. Really what we wanted was fast reads. The issue with the current application I work on is that it's really fast to do inserts, updates, and deletes because of the normalized database. Reads, on the other hand, tend to take a little bit more time. And probably the users use the query aspect of the application probably 80% of the time, and the inserts, updates, and deletes probably the other 20% of the time. So most of the time the user spends in the application is trying to read data, whereas we probably dedicate more time to make the modification of the data a bit more faster. We wanted the application to be scalable, so we were anticipating we were very optimistic and thinking, hey, this application is going to take off, this product's going to take off, people are going to be using it, we're going to have millions of users very quickly. So we wanted to be able to scale out pretty quickly if we needed to. And because we were building this in a somewhat agile way in terms of just building core pieces, trying to release them out, and then based on users' feedback, trying to modify those and then add more features, we need to be able to change quickly. And we wanted to be able to change the application quickly in terms of not so much understanding what should change. I'm sorry, I just need to move this out of the way real quick. Not so much what would change, but being able to target our changes, be able to update just specific parts to the application without having to do perhaps maybe a full recompile or a full redeployment across the entire application. So those are some things that we were kind of keeping in mind. We wanted to be able to log a lot of user actions within the system. Pretty much everyone wants to do that. We wanted the ease of deployment and management of the application, and since we were a startup, we were looking for something that was inexpensive and preferably something that was free. So it's probably a list of things that most startups probably come up with pretty quickly, and this really was just high-level goals in terms of what we wanted the application to, kind of how the platform was going to be. So as a result of all these things, we decided to go with Windows Azure, and there were a couple of reasons for that. Probably first and foremost, and I don't have it listed first, was it was fairly inexpensive to move to Azure. We were registered as a BizSpark company, so as a result of that, in addition to the ultimate license that we get from MSDN, there are also a series of benefits that come with that. Essentially 1,500 compute hours for a small instance, which is great for getting something up and running. It's not going to handle millions of transactions, but at least in terms of prototyping and things like that, that's basically 2 machines, two instances a month for free that you get. 5 gigs in SQL Azure, small cache instance, 2 million transactions a month, and there's a number of other benefits there. So just from a cost perspective, Azure was very appealing to us. And then also just the familiarity that we had with it. So I've worked in the .NET world for a number of years. I'm familiar with Visual Studio. Our current product that I work on at Resources is pretty much on the Microsoft stack. So that familiarity it carries over very nicely. And then also scalability. So being able to move into the cloud was also very much an appealing aspect to this, and being able to add new instances when we needed to fairly quickly. Coming from Resources where our application is hosted at a third-party provider, having to procure new resources and being able to deploy them out and handle all that is really a pain, and it can be a very time-consuming process. I mean, some providers it could take weeks to get a new server in their environment. We've had that situation before with a previous provider who I won't mention. But with the cloud, I can roll out new instances in my environment fairly quickly. It takes 10, 15, 20 minutes to deploy out to Azure, I guess, depending on the number of instances they have to spin up and things like that. But compared to having to go through a procurement process and try to negotiate with a third-party provider, that 20 minutes is a small price to pay in terms of in comparison to a traditional provider. So those are the reasons we decided to go with Azure. And so that decision was pretty quick and early on. But then the bigger question was, well, how are we going to store data? How are we going to design a system? What was the architecture going to be like? And so that's kind of where more of the question marks came about. So I decided to do a little bit of research and dig around and see what was out there, what were some of the ideas floating around, and that kind of stuff. So in terms of that, of course, I would consult where pretty much anybody would consult. I went to Stack Overflow. So I asked a question around Windows Azure Storage versus SQL Azure, because I wanted to see, should I keep my data in Azure Storage, table storage, or should I just go with a traditional database and just host that out in the cloud? So I was just trying to see, had people done this before? What were the pros? What were the cons? Were there any perhaps tools or frameworks or best practices around that? So it was all fairly new. So of course I asked the question, and I got a number of responses, but one that really came to the top, although it was a later response, was one by a guy named Rene Abdulin. So I may be butchering his name, so I apologize. But he basically, within his answer said he would recommend start looking at CQRS style architectures. And so I had heard of CQRS and I knew how to spell it, but I wasn't really sure too much about what it really entailed and what were some of the benefits and what really was involved in putting together a CQRS architected application. So I started digging around and reading up on writings by Greg Young, Udita Hahn, and Jonathan Oliver, and Rene Abdulin. Also, he has a nice set of articles. So at the end of the presentation, if you guys download it, there's links to most of these guys' blogs and some key articles that I came about that really helped me make some decisions. So as I started digging in and researching all this stuff, I kind of came to the point of kind of information overload. So this is kind of me either freaking out or head spinning or just being really excited because once I understood what was going on, it really started to answer a number of questions for me. And I really thought to myself, this really is a good architecture to really consider using for a number of reasons. So I think it addresses a few traditional architecture issues that I've run into in the past. And the one, first and foremost, and this probably may not be the biggest reason to go with CQRS, but this is the one that jumped out at me and really intrigued me from the very start, and has kept my interest from day one. Within the traditional architecture of an application, so I have a normalized database, and I want to go and get all the orders for user data in the last 30 days. What would that query look like? So if I have a fairly normalized database, which probably most applications do, it would probably involve a number of different tables being joined together. So this is the AdventureWorks database. And really, to pull some really relevant information, I would probably need to tack on a few more tables here. But the problem is, I didn't really have room on the slide. Translating that to SQL, go slide, okay. Translating that to SQL, it's fairly complex for a basic question of give me all the orders from me in the last 30 days. I'm dealing with 1, 2, 3, 4, 5, 6 inner joins. I'm joining together all these things. So yeah, I can get that information out pretty quickly, but over time, that can really start to bog down the system a bit if I start doing a lot of joins and I start getting tons of requests and I need to tack on more information to my query results. So this has always been a problem, and especially with reporting, this essentially starts to kill you. But this is what the users are going to want most of the time. So it's always been a thorn in my side. So CQRS presents to me maybe I could take advantage of a query that looks something like this. To me, I like this. There's no joins, so there's just one table that I'm pulling this data back. So it gives me pretty fast reads. Of course, there are prices to pay for this, but if a user is using the system and 80% of the time they want to get information out, I want to make those queries as simple as possible and as fast as possible, and I want to get that data out as fast as possible. So you can take advantage of CQRS to do something like this. You don't have to, but you can. And in looking into it and playing around with it and building it, this does work, and it's a huge benefit, or at least was a huge benefit to me. So, of course, as I was saying, some traditional architecture issues, a lot of apps cater to modification operations at the expense of reads. The other big issue, and I'm sure we've all experienced this, is that your business logic or domain objects tend to bleed very easily through all the different layers of your application. I've seen I tend to kind of browse on Stack Overflow once a day for a couple questions or something. But I've seen lately that there's a few people asking questions about, well, should I just return my domain objects back to my user as my data transfer object? And I see that and think, no, why would you even consider doing that? But that is a problem that I think is pervasive through the industry, that people think, well, I have all the fields I need in my domain object, I'm just going to pass it around, and that's great, it's reuse. But the thing is, what you end up doing, though, is you tightly couple that business object across your application. You start getting into the evil of cut and paste development. Well, I have some validation logic in this business or in this domain object. I'll just use it on in my controller and make sure that everything's cool there before I even get down to the business logic. And as a result, I mean, you end up having your business logic kind of spread throughout your application, and maintaining that then becomes very hard, and you tend to start coupling all your different tiers together. And so making a simple change then becomes a 2-week ordeal that you have to deal with. And what CQRS allows you to do is that it's really going to isolate that business logic. It's almost like the king on the chessboard. All your other pieces surround it, and don't let anybody in, and really try not to let the king out. So that it's a bad analogy, but that's what I just came up with. But that's kind of what CQRS, I think, provides, that encapsulation, that protection of your business logic and your domain objects from bleeding out throughout the rest of your application. And what that really ends up doing is it lets your application, even though you may have a lot of projects, and we'll show you a couple demos that, you may have a lot of different small pieces within your application, but they all do very specific jobs, and there's really very little repetition of what those jobs are. So it's a very clean system. It's very easy to update. It's very easy to segregate out work across everybody on your team. And Azure plays right into this and allows you to really do some, I think allows you to build these type of applications very easily and deploy them out. And it just, as I said, it kind of reduces that complexity within your tiers of your application.